Investigation data analysis. Above shows the different blood pressures at their stages. Ideally, when at rest, your blood should be in the category from 60 to 90 to 80 to 120 in order to have an ideal blood pressure. Blood pressure in different vessels can vary drastically from different vessels in the body, such as an average is around 70 to 120 in the heart. However, in the capillaries, it can be from 20 to 30 millimeters of mercury, and the pressure can range all the way up to 760 millimeters of mercury in the veins. The test results for this, when doing the multi-stage fitness test, change drastically throughout the whole exercise. Blood pressure is measured in the units of millimeters of mercury, and are always measured with a systolic measurement and a diastolic measurement. Isometric blood pressure is where the body is during exercise, but is continuous, repeating the same contraction over and over again. This then increases the cardiac output, however, with no or little to no change in the systemic vascular resistance. Isotonic exercise causes a volume overload of the heart and increase in oxygen consumption, heart rate, stroke volume, and cardiac output, and the systemic blood pressure. Sporting application analysis. Heart rate can vary extremely when playing football due to players having to react to different situations. Your heart rate when running with the ball, be at a fast rate, will increase your heart rate, as it has to allow the blood to eject from your left ventricle to treat your muscles over a prolonged period of time. However, for a goalkeeper, his heart rate will be low most of the time, as he is standing in the same position. They'll be moving very little throughout the game. This is because his muscles only need a small amount of blood when doing this. Neuromuscular responses. The go is the stimulus, goes to the sensory organs, which is the signal, then the sensory nerve to the brain, which makes the decision, to the presynaptic nerve. Depolarization is where the waves of the depolarization jumps over the myelin, which speeds up the process. This is called saltatory conduction. ACH is stored within the veins, within the vesicles. The vesicles go to the presynaptic membrane, where it is released the ACH, where if there is not enough ACH, the impulse will spread to the T tubules to open the active muscle sites, which can cause the muscle fibers to contract. The muscle size increase in the number and thickness of the actin and myosin filaments, and increase in myofibril. They can be used for various different forms of exercise, such as strength, speed, and power. The timing of the contractions becomes more coordinated, especially with power, speed, and strength training, in order to meet the force generation required to move loads. Increase recruitment. So they increase recruitment of additional motor units, which increases the overall force of the contraction. The neuromuscular control of movement. Neuromuscular junction. The neuromuscular junction is a chemical synapse formed by a contact between a motor neuron and a muscle fiber. It is a neuromuscular junction that motor neuron is able to transmit a signal to the muscle fibers, causing the muscle contraction. A neuron must be stimulated, which means that it gets sent down from the axon. It creates negative space, which makes it polarized. As there is a lot of positive atoms on the outside of it, these can only go down the axon at the same speed and power. However, depolarization is where the impulse, which is also known as action potential. This is where depolarization quickly moves down the neuron. This can vary the speed with more than one depolarization taking place. The peripheral nervous system is where the myelin is formed around the cells as they wrap themselves around each other around the axon. This then creates the gaps on the axon which allow the impulses to jump from each gap, which makes it more faster. This is called data reconduction. The motor unit recruitment. Motor unit is the nerves plus fibers which control it. They can only make 3 fibers contract, so over muscle fibers they have to control by other nerves. Your eyes might only have 3 motor units, however in your quads they might over have 1,000 motor units. The brain sends impulses to recruit more motor units for a small force. However, if we need a bigger motor unit, we would use as many as we can. They can always be different in size, so smaller motor units can be for finer movements, such as moving eyes. There are different fibers when doing the multi-stage fitness test, which would use the slow oxidative muscles because we don't need a lot of force, and it uses oxygen because we use our aerobic system when we use a little bit of it, which is low intensity. When we work at a moderate level, we use fast oxygenated glycolytic fibers. When we sprint at the end, we would use our fast glycolytic fibers. These use the same motor unit, so they all have the same, however they use different motor units, so they can all use different fibers. These are wider in diameter, which can move more force and contract harder. Proprioceptors. Proprioceptors controls the movement that gives our brain feedback about movement. Muscle spindles is where the sensory information goes through to the spinal cord. It inhibits the hamstrings so they contract. These monitor the changing length of the shortening and lengthening and the speed that they do this. The reflex goes to the spinal cord through the sensory organs, usually the ears or eyes, which then goes to the sensory nerve, which goes back towards the sensory neuron. This then sends an impulse to the hamstrings, which makes it rapidly go upwards, which stops the contractions, which makes the quads contract. The interfusial muscles, which is an anticipation to contract, preload before you lift something heavy. Golgi tendinate organs. These don't change in length and monitor the tension of the organs. If we use a heavy weight which is too much for our muscles, when they relax, so we don't overcontract our muscles and stretch them. They have opposite roles of the muscle spindles when they relax the muscles. The inverse stretch reflex is where your muscles get forced to inhibit themselves to stop them overstretching to prevent them from injury. This is the same when you get a hammer and tap your knee. Your quads will stretch out and your hamstrings will get inhibited due to the impulse from the motor neuron. Investigation data analysis. The Wingate test would use glycolytic fibers, as the intensity for the Wingate is done over an extremely short and powerful distance. The fibers will contract extremely fast, with lots of fibers being recruited for an explosive movement. However, the strength and rapidness of the contractions mean they'll fatigue very quickly, which means they have to use the lactic acid system to help them to get the rest of the 20-second cycle, as the fast glycolytic fibers will only get them to around 7 to 10, so the lactic acid system has to do the rest. This means that when the fast glycolytic fibers get used up, they use the rest of the lactic acid at a very high rate, and when we compare them to the multi-stage fitness test, they both use around the same amount of lactic acid. So this shows how intense the Wingate test is if we build up the same amount of lactic acid as the multi-stage fitness test. Sport application analysis. In football, when the body will use the neuromuscular system, and it will be used in various different scenarios, the brain works out which fibers to use relative to the activity they need to do, if that's sprinting or jogging or walking. When sprinting, the brain will recruit lots of fast glycolytic fibers so they can contract rapidly for an explosive movement such as sprinting or kicking a ball. The CNS system will also help the player by sending impulses to the brain to the limb being used to make the contraction to make the player do the activities such as shoot. However, when jogging, the brain will simply recruit slow oxidated fibers as there is no explosive movement needed, and we can use the aerobic system whilst doing this. This also helps your fast glycolytic fibers to recover again for another explosive movement, and then when you're walking around the pitch, if there has been a throw-in and the ball goes out of play, they will also use the aerobic system as there is no explosive movements to be required. At rest, the aerobic system produces energy to exist. However, when we do exercise, we use different systems for different scenarios depending on what's going on. The three types of energy systems: ATP-C, an aerobic system, and lactic acid. The ATP-C will use over very explosive movements, but yet short periods under 10 seconds. This is mainly for maximal intensity activities. The aerobic glycolytic is mainly used under high intensity activities, where the aerobic system, however, won't last longer than 10 seconds. The aerobic system is for low intensities, such over a longer period of time. This, however, will always take longer to start, around normally 10 minutes, due to the fact that there's such a complex and long process to get to the oxygen to reach the muscles. They will all be used at the same time, however, they will just be used in different ways, such as an explosive movement will also use an anaerobic glycolysis as well to help.